Madhuri, bearing roll number 19BQ1A04E8. Today I am here to present a topic in digital image processing. My topic is need of image transform. First of all, what is an image? An image is a two-dimensional function f of x, y, where x, y are the spatial or plane coordinates, and the amplitude of f at any pair of coordinates x, y is called the intensity of the image at that level. And next, what is digital image? If x, y and the amplitude values of f are finite and discrete quantities, we call the image of a digital image. A digital image is composed of a finite number of elements. Is also called as pixel, each of which has location and value. And next, what is need of image transform? Need of image transforms. Image processing operations can be applied both in spatial domain and the frequency domain. Many imaging operations can be directly performed in the spatial domain by manipulating the pixel weight. The main advantage of the spatial domain is separation in the tray can be visualized easily. However, the same operations can be done in frequency domain which deal with the frequency components of the image. Some of the real-time applications of image processing are biometric applications such as fingerprint-based attendance, airport baggage, etc. The change of domain for image processing operations will be convenient for process, and we can also gather more detail about some object by changing the domain. Some of the practical applications of the image transform are certain operations are easy to perform in frequency domains compared to spatial domain. For example, the convolution operation can be reduced to matrix multiplication in the frequency domain. This leads to faster execution, efficient design of algorithms. Transforms are useful in gaining valuable insight into concepts such as sampling. The property of energy presentation states that the signal energy is preserved. For example, when a transform is applied, the energy of the signal is unchanged. That means the energy of the signal is not changed when the transform is applied also. The property of image compaction states that a large fraction of average energy of the image is packed into a few components. The uneven distribution of energy in the transformed image results in many components having negligible energy. The uneven distribution of energy have negligible energy. The implication is that if a transform is applied, most of the energy is packed into few coefficients, resulting in more zeros and small number. Distribution of energy have negligible energy. The implication is that if a transform is applied, most of the energy is packed into few coefficients, resulting in more zeros and small number. There is an advantage used of design compression algorithms. Image transforms helps to design faster algorithms. This transformation is obtained in spatial coordinates x, y or x, y, z. These are main advantages if the spatial domain image is transferred into another domain, in which solution of any problem can be found easily. Following are the types of transformations. Fourier transform. Fourier transform is mainly used for digital image processing. In the Fourier transform, the intensity of the image is transferred into frequency variations and then to the frequency domain. It is used to slow varying intensities images such as background of the passport size photo can be represented as a low frequency component, and the edges can be represented as high frequency components. Low frequency components can be removed using filters of FT domain. Then an image is filtered by using the FT domain. Also, if we do inverse FT domain to spatial domain, then also contains image, and the transform is simplest technique used, which edges of the image can be fine. Discrete cosine transformation. In discrete cosine transformation, coefficients carrying information about the pixels of the image and also much information is contained using very few coefficients, and the remaining coefficients contains minimal information. These coefficients can be removed without losing information. By doing this, the filter size is reduced in the discrete cosine transformation domain. DCT is used for lossy compression. Properties of the Fourier transform are as follows: symmetric, unitary, periodic extension, sampler Fourier, fast, conjugate symmetry, circular convolution. And applications of the image transform are as follows. Fourier transform is used as image edge detection. Discrete cosine transform is used as image compression. Thank you.